Hey everybody, welcome back. Welcome to another 3D Hangout. You got myself, Noe Pedro Ruiz here. I'm a designer at Adafruit.
What's up everybody, I'm Pedro Ruiz, the creative technologist here at Adafruit, and every week we come to share 3D printing projects featuring electronics from Adafruit.
That's right, this is the show where we take a look at some 3D printed projects, we combine them with DIY electronics to inspire you guys to help you with your projects. So Pedro, what is on the show today, man?
That's right, every week we have a lovely assortment of cool segments. We start off with what are you prototyping?
Okay, get a look at behind the scenes, what's in the future works.
We'll then jump into 3D news.
We scour the nets to find some interesting stories to share with you folks.
We'll take a look at weekly video, 3D printing project every week.
Every week we have a 3D printed video. It's a video that is somehow 3D printed. We'll take a look at our layer segment.
That's right, every week we'll show you how we created said project for this week.
Okay, and we got an extra bonus Q&A session. We answer your YouTube questions here on YouTube.
That's right, you got questions, we have lots of answers.
We got answers this week.
All this and more on 3D Hangouts.
That's right. Okay, first up, we want to share with you folks
Coupon code.
Coupon code. This week it is Keycap. Get yourself 10% off on the shop at adafruit.com.
That's right, use code Keycap during checkout, get some awesome 3D printing accessories, filament, 3D printers, and of course, electronics for your next project.
Okay, let's start off with what are you prototyping? Pedro, what is this? Last week, you got some drone stuff. This week, update to the drone project.
Yeah, so last week we were testing out some prop designs, and we were testing out different filaments to try to achieve, a nice, rugged, reliable, prop guards that were, pretty durable and pretty break so easily. So we started off with the carbon fiber from
Proto-Pasta.
Proto-Pasta,
Okay.
yeah. So one of the things that we realized right off the bat was that it was a little bit a little brittle, a little bit more brittle than PLA in some cases. So
Really?
A couple of minor crashes really wrecked this. So actually forced me to redesign the prop card, and it's something a lot more simpler where it's just grabbing onto the motor instead of trying to have this little part here that connects to the bottom. Yeah. So we cut all that out. We cut all the all the fat here where it easily broke, even no matter how thick we made the little support here. So just split that up. We're able to make that a little bit shorter, skinnier, and still maintain the strength.
Okay.
So we had some XT filament from ColorFab, which is the copolyester PLA filament. It's you have to print it at 250 degrees, and it definitely was less brittle than the carbon fiber. Had a little bit more flexibility, but it still managed to break even on crashes that weren't so hard.
Okay.
And it turns out that it didn't weigh. It actually weighed 0.1 grams lighter than the carbon fiber.
Oh wow! So
yeah, so the carbon weight. Yeah, so the carbon fiber here, it's reading at 1.1 grams, and XT stuff is reading at 1 gram.
Okay.
So after that experience, we were like, okay, let's go ahead and try ABS. So ABS is the filament that we actually started printing with when we first got into 3D printing. It's a little bit harder to print. Most 3D printers don't come with a heated bed anymore, so which is why we try to stay away from it.
That's right.
And also because the big parts that we print, the ABS would just crack in warp. Yeah. So it's a small little part. It takes about 5 to 8 minutes to print. So we decided, let's go ahead and try it out. It's definitely a lot
stronger,
durable. Yeah. So I was full speed running into the door with this guy, and the flexibility on this really, held up.
Really held up pretty good.
Now the thing we weren't expecting was the weight. And we just took a look at these two. The carbon fiber is supposed to be
thinner, stronger.
Stronger, lighter. XTC was actually lighter than it, a little bit more stronger than it. And ABS weighs 0.6 grams, so it's almost half
a gram.
Half the weight of the carbon fiber or the PLA.
We were saying last week that about a gram takes about a half a minute away.
Yeah.
So you're saving about maybe 30 seconds of.
Flight time. So very durable, lighter. The only problem, the only con here is that you need a heated bed. Yeah, so but because of how small this is, it takes about 5-8 minutes to print.
Yeah.
And a lot of printers also offer a heated bed upgrade.
Oh, okay.
You're not completely out of luck. yeah, you're not completely out of luck. So you might be able to print this on a non-heated bed with, you know, spray, hairspray, or a glue stick. So that is the tests on, you know, making some durable, lightweight prop guards.
Now take a look at
drone.
Now tell me a little bit about which printers did you use for these. Somebody was asking if you could print carbon with the PrinterBot metal.
Yeah, so all of these were actually printed on the
PrinterBot metal.
PrinterBot metal, yeah. The ABS was actually printed on the Orion Delta printer.
Okay, yeah, that is one of the better 3D printers that we carry in the shop that do have a heated bed.
So
yeah, it came out really
excellent
well
on that. Yeah. Just heated it up to 100 degrees on the bed and just printed at like 230 degrees. Okay. And this came out perfect, no warping. And yeah, you can definitely, in our tests, see, yeah, I mean, we really wanted to carry these other filaments, but it's not really worth it when, you know, they're stronger.
We carry some ABS and PLA in the shop. Carbon fiber is from Proto-Pasta, the folks over at Proto-Pasta. And then who's this one from? This is XT material from ColorFab.
Yeah.
So ColorFab holds that. How much did the PLA weigh?
PLA actually, I think it weighs about a gram. Right? Yeah.
So carbon, PLA, and the XT, they all weigh the same.
Yeah.
It's crazy.
The carbon, well, it just depends on sometimes where you're putting this, but yeah. 0.2 grams there, so yeah.
So I really like this test because there's a lot of fun into it first. You know, we wanted to make something really cool, more like dress it up, but now we're really focusing on like how do we optimize it, get more flight time, and sort of save our props. So this is really one of the coolest projects that really takes a look at strength, durability, and really tests it, right? So I really like that. Very cool. Are you going to come up with a...
yeah, we'll release STL files. Or, this is definitely a
materials,
research.
Materials research, okay.
So pretty cool little experiment there on checking out, durability and weight on flight times for a drone.
Very cool.
Next up,
continuing with the filaments and different materials. Last week we were showing you some parts that were printed in new metal filament brass from ColorFab. This week we have all three here, all three metal filaments from ColorFab. Let's get them organized here. There's a little bit of, I want this one over here. Bronze in the middle, and then last third is the brass, and we'll say why in a little bit. So these are all the three different types. Copper over here on the side. Let's take a look at just a visual difference. What do we have? We have color differences, right? This one's a little bit more red. Okay, got a bit more brown and a little bit more green and yellow over here on the brass. I'm really liking this this copper stuff because it really has the best shine, I think.
It's like a rose gold.
Yeah, rose gold. And the next thing to compare is weight. These are actually all different types of weight, same infill, same printer settings and whatnot. The copper stuff comes out at 290 grams, so that's pretty heavy. Brass stuff coming out at 280, so 10 grams lighter, and then 190 for the brass. This is a significantly lighter material. And like we were showing you guys last week, when it comes to quality and surface finishing, this one needs a little bit more help. We got a little bit of a... Can you hold this for me for a second, Pedro? Let's see if we can get some better focusing. You got better focusing? Great. So you can see there's a little bit of holes. You can probably buff that out with a little bit of elbow grease, but straight out of the printer,
out of the tumbler,
straight out of the tumbler, into the tumbler. That's what it kind of looks like. It doesn't have that much of a shine to it. Now compare it to this copper stuff. This is just a beautiful.
Keep in mind that these were all in the tumbler for the exact amount of time.
Yeah,
they were printed at the same G code, just different metal.
That's right.
So you can definitely see
the temperatures or the recommended settings are pretty much on the same across the three. So that's why we ended up using the same file to print. But we just wanted to get a quick visual difference here. I'll go ahead and just.
No, you're good. You're good.
You're good there? Okay. Cool. So, I mean, definitely really loving the two materials. We already carry these two in the Adafruit shop. We got the bronze and the copper fill for you guys. So this is a cool look at just comparing all the metal filaments together. Some are heavier, some are softer. Again, some are more shinier, like these two. I do want to say this one was a lot more softer. We definitely had to loosen the bed a little bit so that it wouldn't break when we removed the part. I remember I was talking about last week how I took this part off and there was a breakage and splitting here, so there was a little bit of a adhesion problem there, but you can definitely do it. These are pretty cool. We think as far as like the contest goes, we're thinking maybe first, second, and third place. It would be pretty cool. Again, this is for the Adafruit Droney Awards contest, the film festival that we are holding. And we are still working on it, folks. It is, it's been a crazy month, and we're still working through a lot of different things, but we are definitely still working on it. And then this is just a nice little comparison of the metal filaments.
Yeah, very cool.
Okay.
All right, let's go ahead and jump into this week's news.
All right, you said it. You said it, so let me set it. We're gonna start off with photos. Bring it up here.
First off, we got a very cool cosplay 3D printed project.
That's right. This is from Mad Max. Everybody wants to see this movie. Anybody who's seen the original definitely is looking forward to this one. The folks over at Carry the What designed and printed the mask from Max's mask.
Yeah, that's right. This is
Cool.
Chris and Cindy, who sell a lot of the open source printable designs on their Etsy shop.
Yeah, look at these photos. These are really great.
Yeah, they're using the Rust-Oleum soft flat iron spray paint to get the very metallic look of this cool prop. They're using Ninja Flex as the cord to keep that strapped to their face.
Totally, and this was printed with support material, I'm assuming. And you can pick it up now you can download it on their Thingiverse page. I think they also sell it on Etsy if you don't have a 3D printer and you want to get into it. They sell it too, so it's pretty cool.
Very nice, simple design.
It's a low poly design that works really well for this little prop here, and I think it's pretty good. Pretty good. If you look at that, and then that from the movie, a little clipping from the movie, looks pretty on par. Yeah.
Yeah, it's pretty close. Yeah.
Cool.
It's like the thing to do now in 3D printing. Any new movie that comes out,
make the prop. Yeah.
Check out the props and build it for real before the movie even comes out.
Yeah.
So very awesome. Big ups to you, Carry the What.
Yeah, Carry the What. What? Okay. Next up, we got another cool project. This one is the TyPhone.
That's right. This is the Hackaday IO project. This is by an awesome 14-year-old maker, Tyler. So
we don't want to butcher your last name, but I'm going to take a stab at it. Spadginski. Yeah, so it's basically a 3.5-inch touchscreen. It's got the Adafruit Phona module, 1200 milliamp with power boost to do the power, and a 5-megapixel camera, and of course Wi-Fi and microphone. Very, very cool. Let me show you guys more photos of it while you tell me some features, Pedro.
Yeah, so it's using the, I think it's the 5-megapixel camera that's on the back there. Okay. And it's using Phil B's very awesome CamPi project, modified version of that to run the photo taking app. Got a cool little speaker in there, and you have your microphone in the back there. Very awesome project.
Does it make phone calls?
Yes,
well, yes,
it totally does. Yeah. Tony D was very excited to print this. He made one for himself for the weekend.
Oh, really?
Yeah, there's a
shout out.
There's a lot of awesome Phona stuff coming your guys' way.
Totally. So this is a great project. It is available on Thingiverse, I believe, with the instructables as well.
There is an instructable page where you can get all the STLs and the step-by-step walkthrough on building your own.
Yeah. And it's featured right now on Hackaday IO. Very, very cool. And I think this is a really, really cool project. Tyler, shout out to you, man. You definitely got to show this off on Adafruit Show and Tell. We invite you to come on.
Yeah,
so that we can. So Phil can probably offer you, something to make a tutorial on the Adafruit learning system.
This is definitely one to make. Yeah, you can just see the camera module there. Just take some photos, and then later in the video, you can check out on the blog. Yeah, he just makes a call.
Calls himself, I think.
Very cool here.
Okay, awesome. All right, next up
we have 3D printed R2.
Oh, is it the R2D2?
R6?
Okay, give me a sec here to sort this out. All right, we got an update from Mr. James Bruton from XRobots. This week, we're taking a look at the R6 droid from Star Wars. This is a fully 3D printed R6 droid. Fully 3D printed, DIY electronics. This thing moves. A couple weeks ago, he was sorting out the electronics. This week, he's sorting out some Arduino code and figuring out where to mount everything properly. So he's figuring out he's going to mount it, 3D prints some brackets, and he's taking a look at some components, going some Adafruit NeoPixels, maybe the Adafruit soundboard to do some sound effects. Very, very cool. Walks us through his Arduino sketch, which is available on his GitHub for free, so you can check that out. He's doing some servo mixing, making sure he's got some constraints so all the values and things work out so that you can turn the right ways. Right now it's a little bit wonky to steer it, but he manages and goes through it all, figures out all the things. He's using a couple different motor drivers to make everything work, and he's sorting out all the wiring and cabling. Very, very fun to watch him do all this. This is about a 30-minute video. All of his videos are about that long. Very, very thorough. I love watching this stuff. And you can see he's sorting out more driver stuff. Here it is, figuring out some mounting stuff. I really like the battery box here. He's got a little matrix LED display so you can see the voltage for the batteries. That's a nice touch. More 3D printing. Very, very cool. Definitely check out his YouTube channel to see the whole build. Here he is, the finale, driving it around. Very, very good at steering it now. And then goes through some more motor drivers and more code, and then ends the episode off with a little head turn and then spinning around in a circle, just like you would see in a droid. Again, this is fully 3D printed, open source design. You can download it now. Code, he's going through it. Yeah, he's still building through it, all the details and stuff. Very, very cool. Definitely can't wait to see it all finished. It's getting very, very close. He's going to keep it, remember the plan is to keep it all open. He's not going to close it off. It is definitely a open frame design so that you can see all the components in there. It's a work of art that way. You know, it's a shame that everyone else kind of covers it up to make it look like the thing, but very, very cool to see all
there's going to be a
electronics.
ton of lights in there, a lot of NeoPixels inside
cool
there,
in
so
there.
definitely can't wait for that one to be completed.
Yeah, check out James Bruton on his
XRobots.com.
YouTube channel. Yep, XRobots.co.uk if you want to check out that. All right, that's going to be it for the news, folks.
Let's go ahead and jump into this week's cool project video.
Okay, we'll take a look at this project video. When we come back, we'll take a look at some comparison it to FDM and maybe a CAD tutorial. So we'll be back in just a second, or a minute. Coming up, we're making custom keycaps. So a few weeks ago, we were chatting with Colin, and he was wondering if it was possible to 3D print custom keycaps for mechanical keyboards. So we thought, that's a pretty good project idea. So this is a mechanical keyboard with Cherry MX switches. It features a customizable layout and LED backlighting. It comes with extra keys, which is really nice, but there's a lot of cool stuff we could do by 3D printing our own. These keycaps are held by a connector piece that's in the center of the key, and it just easily snaps on. We made these on the Amber DLP SLA 3D printer from Autodesk, and we printed them in clear resin, which diffuses the LEDs quite nicely. Whoa. The size of each keycap is different, so it's important to take note of all the angles and curvatures, because they're kind of all different from each other. So we start by taking measurements of the keycaps using calipers. Then in CAD software, we'll draw up some simple sketches and loft between them to create the basic shape. We then applied a small fillet of 1.25 millimeters to the edges, and a shell with a wall thickness of 1.25 matches up with the original keycap. To create the curvature, we subtracted an oblong cylinder from the top surface, which is just an easy way to create a slight contour. Next up, this is the really fun part, because this is where you can make whatever your creativity allows. So we put together these 3 custom keycaps. First up, a skull key with vampire teeth. This is a cool one just to test fine details. A command key with a raised symbol, so that way we can sort of feel for the key that avoids looking down. And then for fun, we made an escape key with a little Adafruit logo on top. We released the source file so you guys can download it and modify it to make whatever you want. These are rather small objects with some really fine details, so it's probably not going to look so well on an FDM 3D printer, so we think this is a really good job for our resin-based SLA machine. To orient the part and add support structures, we're using Mesh Mixer. We'll lay it flat on the front side, which has a decent amount of surface area, and this will make it so the layers stick to the bed. The default settings for support structures tend to generate non-manifold geometry, especially on really small parts, so we lowered the tip layer option down to 10 to 15, and this will avoid generating any weird geometries when creating supports. We'll also drop the tip diameter to 0.3 millimeters so that it's not so thick. Now when we create support material, they'll come out nice and clean. A few more here on the side of the connector should be enough for it to print properly. Once that's looking good, we'll export the STL and upload it to the printer. So how long does it take to print? We're looking at about 40 minutes to print just one key, and this is at 50 micron resolution. If you drop it down to 25, the print time goes up to about an hour and a half. And there really isn't much difference between the two, and you end up getting similar details. Now to remove the print from the bed, we're going to use a flat spatula, and this will just help release the part from the build plate. This one just kind of popped off nicely. To remove the support material, we'll use our Haku flush snips, and this will help break apart the structures. Tweezers will also help remove the little tiny bits, and then we'll start from the front and sort of work our way towards the back. To cure the part, we'll pour on some alcohol over the keycap, and this will help harden the material, making sure that we get the insides as well. Then we'll pat it down with a paper towel, and we'll let it dry for about 10 minutes so that it fully cures. How about tolerance testing? Testing for tolerance is always sort of a back and forth process of adjusting thickness to get that snap fit. So it did take a few revisions before getting a solid keycap. But there you have it, custom 3D printed keycaps. We think this would be a pretty interesting accessibility project. Embossed keycaps would work really well for a Braille keyboard, am I right? You can also let us know what you'd like us to build next. And if you're interested in more CAD and slicer stuff, you can tune into our 3D printing show every Thursday. And if you haven't already, you can subscribe for more weekly videos from Adafruit. Guys, I'll see you guys in the next one. Bye, everybody. All right, and we're back. That was a very cool project, Pedro. Let's take a look at some comparisons. We got two different keyboards here. I just want to show everybody here the differences between the two. All right.
Yeah, so in case everybody was wondering, Colin's favorite keyboard, which he made us go out and get, is the KB Paradise V60. This is an awesome little mini keyboard that took a little bit of getting used to, simply because we're Mac users, so we're used to having the command key right next to the space key. So I personally printed these out to just have a feel for where the command key is supposed to be.
Okay.
Very nice little mini one, but I needed a arrow key, so I got the KB Paradise V80, which just has the function keys, which I really don't like. I wish it was just from here down with the arrow keys. But nonetheless,
are the keys themselves the same though? Like
the keys are the key stem that is which connects it to the Tarium X switch. Those are the same. What is different though is depending on what row that you're changing, the degree of the curve is going to be different.
So when it's angled a little bit different, it's elevated differently, huh?
Yeah, so when I made the skull, well, it's the function key on the small one and the keycap on this one, they're on different rows, so the degree that you had to use for the curve changes. I think this one is 5 degrees, this one was 8 degrees. So there is a difference in that. This is why we gave away the 123D file so you guys can edit it. And we just wanted to show differences in what it looks like in FDM and differences with a SLA DLP printer. So right away you can see that printing in transparent material, PLA right here, the one I'm shaking, it quickly loses, or it quickly becomes opaque as soon as you start stacking a couple layers on top. So for transparency you definitely lose that. And this was printed at I believe 100 microns. So
which printer?
I think this was on the Orion, I believe.
Okay.
And just regular PLA, transparent, and you can definitely tell the the difference in quality and detail. Yeah, you can see all the little teeth, all that.
Now this wasn't actually as high res as you could. 50 microns is pretty high.
Yeah, so this is 50 microns. Some printers can print at 50 microns,
right?
But you're definitely not going to get this type of finish. I mean, this is
you just don't
this
see
looks
the layers.
this looks like like ice, transparent ice. It's the resin, and of course the quality that you get on the key stem is phenomenal.
There you go. That looks great. Okay.
So you get extremely high detail on tiny little parts like that.
Pretty good tolerances as well.
Yeah, the tolerance is pretty spot on.
It's pretty spot on.
Yeah, so because I designed these for SLA, you're definitely going to need to update these, which we'll go over in the layer by layer.
Sure, yeah.
And of course, we wanted to see what these would look like
in metal filament.
So yeah, so this is our favorite shiny
copper
right
fill
here
from ColorFab, folks. This was in the tumbler for a good 4 hours or so. We could probably put it in there for longer, but you can see it's got a little bit of holes.
Oh, yeah.
You could probably fill it up with some of that compound filler that we used last week.
Well, the thing I need to
cool.
do is print this at 150 microns. This was at 200 microns.
And you
right
printed
here.
this
Or actually 100 microns.
on the
sorry.
printer bot, I believe, yeah?
Yeah, this is on the printer bot
that looks
at
nice and
200
shiny.
microns.
Almost
so,
looks gold.
yeah, we need to redo this at 100 microns just to get a better finish out of that. And of course, we got
Steampunk looking.
a
Oh, the keycap, yeah. It almost looks like
Yeah.
wood, huh? With a little bit of grain.
yeah, and this is because of the this is just 200 microns. You could definitely see the slopes on that.
Yeah.
But pretty cool. This would definitely give you a steampunk keyboard if you made all of these, and of course has a very nice weight. Bottom of
Just the
these.
bottom. Which actually came out pretty good when it comes to overhang and how. The
Yeah, there's no
material's a little
support
bit
material
stringy.
on the inside of this.
Yeah.
I mean, the bridging is short enough that it makes it really
It
good.
survived the rock tumbler, man. This is only 2 shells, I think, right?
Yeah, I didn't do any changes on that. I forgot to do it, but yeah.
It worked out.
Can't wait to reprint this at a higher resolution.
That's so great.
Definitely have to edit it, maybe poke some holes into the eye so the LEDs can still shine through. But yeah,
Sure.
it's something you guys can definitely do at home.
All right, we're at the office. Or hackerspace.
So let's go ahead and check out the layer by layer so we can see how to create our own.
Yeah, so when you guys download the 123D file, this is what it's going to look like. We got an assortment of different sizes, different versions. We're going to go through how to create one using the sketches that we are included. So they're actually hidden. Right now you can only see the solids and some of the union stuff, and we'll go through that in a little bit. But
Yeah, I mean,
what you
it's a
want to
little-
do is go to the sidebar over there, and there's show solid or show sketches. There it is, show sketches, and then that's what you're going to work with. Okay.
So as we said in the video, the first thing you want to start off with is just pull off the
Measuring
key,
it, yeah.
take out your calipers, and you're going to want to measure the bottom and the top, and then jump into our file here. And it's simple to edit. You just want to grab these sketches here. You can see the sizes that we use. I think this is the escape key. And you can just simply click and drag these out, and it'll tell you what the measurement it updates to. And you just want to do that for the top and the bottom part of the keycap.
sketch?
Once you get of the sketch, once you get all of your correct sizes for the key that you want to edit.
Okay.
After that, you just select one and then shift select the second one and create a loft.
Okay.
As we said in the video, you want to do a shell of 1.25, and the fillet is the same for the corners to create that nice beveled look.
Now you're talking about how the curvature tends to be different for the row. This is really something you want to look out for. So you're sort of figuring out which is the right angle. Do you
Yeah.
wanna
So
talk a
for the
little bit
little
about-
one, for the little ones, it was 5 degrees when you're
Okay.
rotating it like that, and then 8 degrees on the bigger one.
So a little bit more of an elevation.
Yeah, so that's just something you want to look out for, what row your key is on, that you want to update it and update that accordingly. The second thing you want to watch out for, or that you actually want to do, is make sure that your material is turned on to use the glass
That's right. So you can see
material,
through
so you can
the
see
thing.
through it. And what
Okay.
we're doing here is making sure that the geometry that's going to create the curve is not too close to the bottom wall there, because it is going to create a hole and it's not going to have enough room there.
Okay, so that's why you have that extra thickness. It does look, the top looks a lot thicker than the side wall,
Yeah.
so that's just to accommodate for the cutting here.
Yeah, so when you cut that out, you can see that it drops down a little bit, and you can see one of the sizes actually has less room.
Okay.
Next thing you want to do is, depending on how your the icon that you want to add, you definitely want to make sure that is flush up against the newly created curvature.
Okay. It's
of
not
the
really there
wall.
yet, so you're pushing it inward to make sure you get a nice intersection, and you'll probably want to do some fine adjustments, increments on the rotation on the degree,
Yeah.
so that it's nice and pretty level with it.
Yeah, and you just want to rotate around all the sides and make sure nothing's been moved, everything's still in the middle.
Okay.
It's very easy to move stuff inside of 123D. For FDM, the next thing you want to do is you want to select all of the walls on the inside, and you're going to want to push these out just a little bit to accommodate for the tolerance differences inside of 123D.
Okay.
So I think it should be about -0.4 is what should have a nice grip and tolerance. As you can see on the sides there, it's a little, the wall thickness is a little bit too small. When I was printing these out, I figured out the easiest way to do that was just knock those out. You can just select those 2 walls and just stretch them out past,
Okay.
and it'll just create a nice
Opening for
opening
you.
for
Okay.
it there, and that should print out pretty good, as you saw in the examples that we showed earlier.
Okay. How about support material? It's coming up.
Support material, yeah. So the only thing that you need for support material is the bottom there. So what you want to do is look inside the file. There is a little bottom cylinder.
Well, let's go in order here. I think you're merging first.
Oh,
so
a
tell
big
me about
one, yeah.
merging. Yeah, tell me about merging a mesh and a solid.
Yeah, so the skull is an imported STL, which is a mesh, and when you do a combine with a solid object and a mesh object, it's going to turn the solid into a mesh.
That's right.
Which means that it's going to triangulate it.
Right.
It's no longer editable. So you're going to lose the ability to edit your fillets, your faces, your vertices.
Okay.
That's actually a question that's going to be coming up that somebody asked on YouTube, and that's why you're not able to edit any of that. It's because it turns it into a mesh. And
so you want to be sure that you have most of your edits finalized before you
because you're not going to be able to move just any of your walls. That's why I have so many files in there. It's just a duplicate of something before I do a union on it.
Okay.
So you were talking about support material.
Here
This
it
is
is
included inside of the file. If you just show all objects, this is in here. You just make a copy of it, duplicate it, and then snap the bottom of that to the top of the key stem there.
Oh, okay.
So it'll just snap, a line and snap to the bottom there.
Okay.
And then you just do a merge on that, and you can just see that it turns into a
mesh again.
Everything turns into a mesh there.
Okay.
And the way you're going to print this is flat like this. The little support structure is going to support the key stem up there, and you should be good. I'm going to do this at 100 microns, 150 microns. Otherwise, if you do it at 200 microns, you're going to see a lot of ridges that show up.
Okay.
So again, this is the 3 keycaps that we came up with. Should be useful. I know I should have made like the WS and D keys, but I switched over to the big one, so I have the keys over here. You don't do too much with
right. I mean, it started off as a
arrows.
necessity, like, hey, I really need to change my muscle memory after 20 years of being in the same spot.
Yeah.
You're gonna need a little bit of help. So I think this is a really cool combination of I want to do something cool, test the Amber printer, test the LP, and do this, check out one of this project. Colin came up with a really good project idea. This is one of those things that, really good. Like, why hasn't anyone done this before? Yeah, the people are doing it, but not on these printers. So
yeah, so if you have a Form Labs printer, this should work very good. Go ahead,
definitely let us know.
Let us know
if it
how
works,
this turns out. Post up links. We have a group on the Thingiverse page. Post remix.
I would say try the default supports too from Form Labs. I'm interested to see how well that performs straight out of the box.
Let's see how that.
Doing it with the Amber supports, did you try that? I think you did several iterations.
It's in the video. It's in the video. Remember, it shows the how to make.
That's right. Yeah. That's
manifold
right.
support structures.
Sorry, guys.
Yeah, all that.
It happened so many weeks ago.
So yeah, that's all. The 123D file, STLs, you can get them all at learn.adafruit.com, step-by-step guide on measuring, putting, like we were just talking about, the support material, making manifold inside mesh mixer, all that stuff is in the guide.
I like though that you also made it, here it is for FDM. Speaking of which, if you want to pick up some color fab stuff, some metal filament, get yourself 10% off on the Adafruit shop. Use Keycap at the checkout, get yourself a nice little discount.
That's right. If you want something shiny, definitely go after the copper. You want more of a rustic, darker tone look for your keycaps, go with the bronze.
Okay. Well, that's it for the layer by layer. Let's go ahead and jump in and answer some questions.
All right, let's go over some Q&A.
Yeah, so this is where we answer your YouTube questions. First up, this one's from Charles Foreman on the 3D printing standoffs video. Love this. I want more enclosure videos. Question suggestions. Do you think it would be interesting to do teardowns of interesting enclosure solutions to learn from them? Sometimes I take apart electronics just to see how the enclosure was designed. I would love to see videos of these. I would too. This is a really cool project. It reminds me a lot of Becky's teardown videos with Lamar. If we were in the shop, it'd be so fun to hey, let's take a look at that enclosure and then sort of try to figure out why is it that way? Why are the standoffs like that or whatnot? Very, very cool idea. We have quite a bit in our production pipeline. Quite a few weeks already queued up. So we just now saw this. So we're going to try to figure out what we can do here. I think it's a really cool concept. We're definitely listening to you. And I think it's a cool idea, yeah?
Oh, yeah, definitely.
We'll see what we come up with in the coming weeks.
As the project slow down, we'll definitely take a look at looking at very awesome design enclosures.
Okay. Next up, this one's from Jason Cole on the standoffs video again. What kind of screws are you using exactly, and where do you find them? I'm actually trying to do the same thing exactly like this, but none of the screws I find in the hardware store fit through the mounting holes in the boards from you guys? Very good question. A couple of people are always asking what are the size machines? If you're using imperial size number 440 screws, let's take a look at the overhead. We got a couple screws.
I don't know what the M sizes for these are, but yeah. We actually started finding these at Lowe's. These we got online.
They're pretty pricey at Lowe's.
Yeah, so these are way cheaper online. Just go to Amazon. The link to these are actually going to be in the description to the video, so definitely check those out. So the most popular one that we use is the stainless steel Phillips flathead, so that it's completely flush. We make the bevel on the standoff there, and it's the 440 3/8. We got this, I think, for $20 for 1,000 pieces. And yeah, it's just Albany fasteners. They have a Amazon Market front.
Okay.
Just search for that. Of course, the product's going to be, because it was so freaking hard to find the link for this. So I saved those. The other one that we use a bunch is the smaller number 2, and
56.
these are
256
3/8.
Okay. What boards are these for?
This is for the, I think it was for the Pro Trinket. I used it recently in the syringe project.
Okay.
I needed like
so
the smallest.
something smaller. You get definitely works for the smaller boards with the smaller mounting holes.
Yeah, I think these were like $5 and for like 100. So these are pretty cheap online. I'll find these and we'll try to stock these in the shop as well.
I think so, yeah.
These are pretty popular.
Cool.
So yeah, these are the screws that we use.
Yeah, in the meantime, check those out. We got the link for you guys. Very good question. Let's jump back into the questions. Next one. This one's from Click Zap Gaming on the Mini Mac Pi project video. I don't have a 3D printer or have access to one. Is there someone that can make this and then I could buy it? You probably don't. If you could find somebody to build the project and print it, they're probably going to charge you the price of a printer. So I definitely don't recommend that. But if you're looking for someone to print the parts for you, you should check out your library, your college, your local hackerspace. These are places that are starting to get familiar with 3D printing and offering them for people to use them. So definitely check that out. If you want somebody to if you just want to email the file and have somebody ship it to you, check out makexyz.com or 3dhubs.com. This is a locally directory of makers and hackers who have 3D printers. They're willing to rent it out and do a little bit of service. So they charge you for it and they'll send it to you. So check those out. And hopefully you can get your 3D printed parts and make the projects because they're very fun, very cool.
Yeah, definitely check those out.
Okay. Next question. This one is from Dew Claus on the making replacement parts layer by layer video. Great video and thank you for the time you put in. Could you go over a few tips on measuring and calculating the fillet? Yeah, totally. You're welcome. And this one was a really simple one. You just take the distance between the two. Let's say it's 20, and then if you want that perfect circular radius, all you do is divide that by 2. So if we got 10, you put 5 for the radius, and you'll get a perfectly circular radius. It's that simple. Pretty cool, huh?
Yeah.
Okay. Next up, this is the last one. We'll end it with this one from Jerry.
Remember this one.
If you import an existing STL file, how do you fillet the edges? I can't seem to get it to work. Pedro.
So we actually went over this during our layer by layer.
Pretty much.
If you import something into 123D, it's going to treat it as a mesh.
That's right.
Even if it's just STL that you export out of 123D, because it's going to it's going to triangulate when you export it.
Right.
So yeah, that's the reason why it has to be a solid object. You definitely want to use a mesh editing app like Mesh Mixer if you want to adjust any faces or sides.
Okay.
Definitely want to check that out. It's going to be a little bit more tedious selecting all the triangles because it's not going to know how to group everything together.
Right. But that's probably the most cost-efficient way to do it, I think, and the quickest way to do it is just using Mesh Mixer. A lot of YouTube tutorials, too, on how to use Mesh Mixer, so check that out as well. All right, that's going to be it for the questions. If you want us to answer your questions, just drop them on the YouTube videos. You got a question, ask away, and we'll collect them, and we'll gather them up in a couple of weeks, and we'll answer them here on the show. Yeah?
Yeah, totally.
Okay.
All right,
Very
I think
cool.
that's going to do it for this week. We have a lovely assortment of links where you can follow.
Yep, but also
Keycaps.
make sure to check out the coupon code. Get 10% off on your order. So be sure to get on that. It's going to end tonight.
Doesn't work on software or gift certificates, but you can get all the 3D printing accessories, filament printers, tape,
Breakout boards,
so
many different
electronics.
things. Oh yeah.
For your next awesome project.
All right. So like Pedro's saying, here's a couple links for you guys. If you want to see more projects, there's tons of them. You want to learn some Arduino, learn some code, learn some modeling, check out the Adafruit Learning System. That's where all the projects are. And if you want to come hang out with us, you totally can. There's a Adafruit party going on every Wednesday. It is the Show and Tell show on Google Hangouts. You can get yourself set up there by checking out the Google Plus page. Yeah?
That's right. Every Wednesday at 7:30 ET.
Yep.
Join the party. Get added.
7:30 p.m. ET.
PM
It's at night,
ET.
not in the morning. And every Thursday is, of course, 3D Thursday. We got lots of stories for you guys in the blog, and we got the links in the description below, the stories that we covered today. And if you want to see us, Pedro, where else can they follow us?
Twitter, Instagram, Thingiverse is where we post all of our behind-the-scenes work in process projects.
That's okay.
Check us out. Video Pixel, that's me, or Noe Ekin on Twitter, Instagram,
Yeah.
even Periscope.
Yeah, Periscope's a new one.
Yeah,
If
a
you
lot
want to
of
see some live stuff, check out Periscope. It's also available on the web if you don't have an iOS thingy. But that's okay. No problem there. But yeah, that's going to be it for the show, folks. Thank you so much for watching. We'll be here next week. Next week we'll have some cool projects.
every week. Yeah.
Every week. And a coupon code as always. So until then, folks, we'll see you. Thanks for watching.
See you guys next time.